So what we have here is an integrating sphere, and what we can do here is we can put a light completely inside of this sphere. This sphere is large enough to where we can put the entire light in. For example, we can use a flashlight, we can use a low voltage light, any type of larger light that will fit inside of the sphere. We can turn it on inside of the sphere, and then it will tell us the total lumens, or the total amount of light that's being put out from a light. So I'm going to turn this flashlight on. And I'll set it inside of the sphere. And then what I'll do is I'll close the door. And now the light is bouncing around inside of this white sphere to get a uniform light, which will reach a small light sensor we have on the side. And then what we can do is we have a computer that's hooked up to a system that we can come over and hit start. And what that will do, this will do two things. It will tell us how many lumens the flashlight is putting out, and that is the total amount of light. And it'll also tell us if the light is a white color, a reddish color, a bluish color. Is it more like the sun, or is it more like a candle light? It will tell us a color temperature, and they record that in degrees Kelvin, or sometimes degrees K. So this equipment here is designed to measure the beam distance. And when we say beam distance, that's how far the light will shine and still give a usable light. So what we do is we turn the light on. I have a sensor, a light sensor at the end of this tube. And what we do is we shine the light on the inside at the sensor. And the sensor then will give us a number. You can see the number moving perhaps on the equipment as I move this up and down. What we do is we take the maximum number, and then I can take that number and I can walk over to the computer and I can plug that number in here, for example, and it will tell us that the beam distance on this light would be around 155 meters. That's about more than 1.5 football fields. If you're 1.5 football fields away from this light, you would still be able to function. You'll be able to see as if it was a full moonlit night. Another thing we test for on a light is whether or not it's waterproof. And if we do say it's waterproof, we need to say how deep the water can be and it still be waterproof. So what we have is a tank here filled with water, and we have a tank here to be able to put the light in. So if I take this flashlight, I'll just drop it in this tank, and then I'll lower it into water. And we have it marked here. We can see the bottom, and if it goes completely to the bottom of this tank, it will be 1 meter deep, which is a little bit over 3 feet. And what we do is we let it set in this tank for 30 minutes, and at the end of 30 minutes time we'll pull the flashlight out and thoroughly examine it to make sure there's no water on the inside. If there's any water on the inside, well, then it would fail this particular test.
Yeah, it should be.
What we're doing now is we're going to test a low voltage light, the type of light that you'd have in your backyard. This is a Malibu light. So what we're doing, we're hanging this inside of the sphere, and this wire here is from our power supply that will provide the 12 volts to it that will simulate the transformer, the power pack that normally comes with these lights. So once the light is in, it's on. We'll close this. And once again, what we're looking for would basically be two things, and that is the lumens, or how bright the light is, and also what's the color temperature. Is the light a white light? Is it a red light? A warm white light is what we're measuring here. so what this shows us is this light is very bright. It's over 47 lumens, and the color temperature is about 3,167, which is a nice, pleasant, warm light, which is very desirable for a lot of people in their backyards. And the other thing we can do with this equipment, if we look right here, it tells us we're providing the 12 volts, which is what your transformer would be giving you, and it tells us that this unit is drawing 1.78 watts. So it's a lot of light for a very small amount of power.